Hello and welcome to today's lecture in pre-calculus. Today's lecture will be a little deviation from the intended instruction predefined outline for the lectures in that we will only be going over polynomial equations in this lecture. I found that there's a lot more information to cover than previously anticipated, so I wanted to give ample time to devote to simply grasping the concept of polynomial equations. So in this lecture, therefore, we'll only be discussing identifying what a polynomial function is and graphing and solving them using a method known as synthetic division, which I'm also going to go over very briefly. To be a polynomial equation, an equation must be continuous, smooth, and have only positive integer degree values for all its x terms. And I'm going to right now draw three equations that do not satisfy each of the following. So first, continuous. We have the rectangular hyperbola equation, which we went over and looks somewhat like that. I understand I did not make it straight, so that should do a little bit of a better job. Um, Next, it must be smooth, and this equation will be y equals the absolute value of x, and it should also have only positive integer degree values for all its x terms. This will also be y of 1x, but it'll also be y equals the square root of x. And note that I'm using y, whereas professional textbooks will also try to use function. It's just fancy notation. It means the exact same thing. I like to use y because we have a Cartesian plane where we could have y equals f of x, but I see no reason to just have y. So yeah, let's begin by discussing continuity. The rectangular hyperbola equation does not have a full left to right, does not flow cohesively. There's a little gap. There's a place where none of the values for the functions will ever exist, and that is the y-axis right at 0 for this parent equation. And that's actually called the asymptote, which we will actually be going over in the next lecture when we discuss rational functions. But this asymptote is the point where it's not equal to anything in the function, and it's right in the middle of the graph of the function. Therefore, it's not continuous, and as a result, it's not a polynomial equation. Next, we have y equals the absolute value of x, and I'm going to do my best to try to draw a straight line there to show that this isn't smooth. This is very jagged. It's like a V shape. It's not a curved U shape like our parabola that we discussed in detail last time. It's a very jagged V shape, so it's not smooth. Therefore, it's also not a polynomial equation. Next, we have to have positive integer degree values for all its x terms. It needs to satisfy all these three stipulations. This one, y equals 1 over x, can also be written as x to the negative first power. And why is x to the negative first power? Why does it not satisfy this? Because it's not positive. It's an integer and it's a degree. But I don't understand why why it would not be degree, but we'll discuss that in a little bit. But it's a negative integer, so it's not a polynomial equation. Next, we have the y equals the square root of x, which can also be written as y equals 1/2 x. And because it can be written as y is 1/2 x, it's not an integer value. It's positive, but it's not an integer degree value. So therefore, it's not going to be a polynomial equation either. So now that we know what a polynomial equation is, let's try to solve them. First, to solve them, we need to look at something called end behavior. And this begins our exploration into our polynomial equations. So to examine end behavior is taught very, very differently in various different settings. Some settings it is simply taught to memorize. Other situations it's taught to explain. I'm more of an explanation guy than memorization, because memorization does us no good, and memorization leads to forgetting. So let's just draw these three equations that I've graphed out. Y equals x squared. That kind of looks like that. It's a nice U shape. Y equals negative x squared. That's just a reflection over the x-axis. And y equals x cubed. This is going to be a little difficult to explain, but when you flip it over the x-axis, it just becomes shape similar to that. If you don't believe me, what you're going to do is you can take out your graphing calculator, which I already have set up next to me. You're going to press the on button. Make sure you're completely on the home screen. In the top left-hand corner, you're going to press y equals, and you're going to type negative parentheses x and the caret sign, which is right above the division sign, 3 and then parentheses as again. What this does is to ensure that the negative sign is going over the entire x raised to the third power. And I'm using a TI-84 Plus, if you guys are wondering a little bit what happened. TI-83s and previous models should adhere to my instructions, but later models may not. So I'm using probably one of the most common graphing calculators, and I'm doing so in an attempt to try to satisfy the most people. If you have any problems, be sure to leave a comment, and I will try to assist you in properly using your calculator to get the most out of it to solve these types of problems. So now when we hit graph, which is going to be completely on the top right-hand corner, right next to trace, I'm going to hit graph, and we're going to see that the entire thing is reflected versus x to the cube, which goes up like this. Now, as such, the end behavior deals with the function as it approaches infinity from negative and positive side. Now, over here, the end result on the left is going to be positive, and the end result on the left is also going to be, or the right is also going to be positive. Here, it's going to be negative, and then over here, negative and negative. Over here, it's going to be negative but positive, and over here, it's going to be positive but negative. So how do we memorize these? Normally, a textbook will just say that anything that has an odd and has a positive coefficient and positive degree, positive odd degree will become positive negative, and so on and so forth. And that's very, very confusing. So what I like to do is I like to select two values for x, two large values for x, two large values of x, however, two values of x that can still be thought of in without using too much effort on the calculator side. And I like to use negative 100 and 100. So let's try to see what the end behavior for y equals x squared will be. Well, if x equals negative 100, then negative 100 squared, any number squared, becomes positive. So on negative 100, which as you can see on the graph is way over here, x is going to be positive. So positive over here. It's going to be up here. The end behavior is going to be approaching that way. And when x equals positive 100, 100 squared is still a positive number. It doesn't matter what the number is. It just matters that the number is positive. So because of that, we're going to also say that up here it's going to be positive. It's going to end off like that. And as you can see, we have successfully found the end behavior of that polynomial equation. And this also applies to larger constructs. Let's say we had some crazy polynomial, 5x to the fourth plus 3x cubed plus 2x plus 7. Why not? And we have to find the end behavior of this graph. Now, you might be assuming, oh no, we have to look at all these different terms, but think about it. What's the fastest growing term in here? Well, exponentially speaking, this is the fastest growing term, 5x to the fourth. So as we get to very large numbers, such as 100, such as infinity even, but we're going to work with 100, it starts to become negligible, all these other numbers compared to this. This becomes the central focus. I'm going to increase the brightness again. So now what we must do is we must find simply just look at the end behavior of y equals 5x to the fourth. Well, at negative 100, negative 100 raised to the fourth power, any number raised to an even power is going to become positive. And does the 5 change the sign of our solution? No, it does not. So up here as well, it's going to be positive. And then on the reverse side, x equals 100 to the fourth power, that's going to be even, and the 5 again is not going to change our sign. So we also have that it's going to be, end behavior is going to be up here and up here. Let's take a look at this now. Y equals negative 5x to the third plus 6x minus 7. Again, the fastest growing term here is 5x to the third. So let's just look at that. Negative 5x to the third. And let's say that negative 100 and 100 are going to be our two x values. So it's going to be, we're going to look at. So negative 100 to the cube, negative 100 cubed. Well, this is being raised to an odd number. So if you think about it, it's still going to be negative. But a negative times a negative number is going to become positive. So negative 100 cubed was originally negative, but since we're adding a negative 5 to it, it's going to become positive. Conversely, 100 cubed is positive, but as soon as we apply the negative 5 to it, it's going to become negative. So our end behavior kind of looks like this and this. It's opposite. But if you look back up here, negative x cubed, positive, negative, positive, negative. So don't worry yourselves about learning the end behavior and memorizing them. Just think about it. If you see an equation, plug in two values of x and see what the final end behavior is going to be from there. So now that we know end behavior, what is that used for? Well, it's used if we have to graph a polynomial equation. Let's say I have to graph negative 5x to the 7th power. Well, if I just told you that the end behavior, we have to find the end behavior, well, the end behavior, let's just add a 3 here. Why not? The end behavior of this equation is going to be, well, 100, negative 100 to an odd power is going to become negative. So it's negative, negative times a negative is going to be positive. So it's going to be up here. The end, it's going to end off somewhere up here. And negative wise, it's going to, positive wise, 100 to the 7th power is going to be an even number. Even times negative, though, is going to be a negative number. So it's going to go down here. And since this is an odd degree, the leading coefficient is odd, then we can, with a safe margin, we can assume that it's going to look something like this. It's going to look something like x to the third, only it's going to be very, very, very narrow. And this is going to almost look like it's going to flatline right there. It's going to look like it becomes nothing, but then it goes down again. But is that true? It's partially true. However, notice the transformation. We've added 3 to this, so we got to move this thing up 3. And then the end behavior moves up as well. And there you go. We've successfully graphed our equation. But nothing's going to be that easy. Usually, we're going to have to use crazy mathematics skills in order to solve one. I'm going to come up with the next solution. We're going to keep these easy. We're not going to use crazy polynomial degrees because that requires so much math and it's so much easier to make a mistake that all you got to do is simply just use your calculator. Which leads me to our next point. Let's try to graph this equation on our calculator and see if we get anything close to what I got. If we completely go into the home screen, press again y equals x squared, and clear off that y1 equation that we had, which was negative x, which I told you to graph was negative x cubed. And let's graph this one, negative 5 raised, sorry, I meant to say negative 5 times x, so just put negative 5x raised 7 plus 3. And let's see what happens. I was right. Indeed, it's going to look very, very narrow. It's going to look like it's going to steepen out. Like right there, it's going to look very, very big. And it's going to go like this, then go down. I messed up a little bit in the drawing of this graph, which is why you always want to use your graphing calculator after you've figured it out in your head, just to check to make sure you're right. It's important to understand these concepts because it helps making sure that there's no chance of your error. So now I'm going to do a completely different equation. My equation is going to be, and I figured these out ahead of time, so I know these work out. Y equals 2x cubed minus 24x plus 32. Like I said, if it gets above about maybe 5th power, you're going to want to start using your calculator to graph these equations and just kind of mimic the graphs on there, because at that point, any mathematics you use is going to become so blisteringly annoying and just overclouded that there's no point to trying to do it without your calculator at that point. Here, it's very plausible for us to figure this out without the calculator because the calculator might also try to mess up some things, and we got to know some material in order to do this. Well, to begin, we got to find the intercepts to graph a polynomial equation. The first step is to graph a polynomial equation is to find the x-intercepts. Back when we did algebra as well, that was our first step. We had to find the the x-intercepts. For example, y equals x squared. Let me try to see if I can think of an equation that will plus x plus 1. I believe that factors. No, it does not factor. I'm sorry. I was just thinking there for a second. It does not factor. but we had to find factors for equations. Let's go backwards, actually. We had to find factors for our equations. So we had to assume that our factors were going to be x squared and x minus 2. And we're just going to use FOIL real quickly to figure out that equation. X squared plus 6x minus 2x minus 12. I've been told I do my FOIL a little differently than most people. It's just the way I look at the equation. So y equals 2x plus 4x minus 12. That should work because then it becomes 6 and 2. Yep. So let's completely go back there. We had to find our intercepts in order to find a solution. If we had to solve this, we had to find the points at where y equals 0, and when y equals 0, the points at which x existed. So to do that, we had to find properly find solutions to our equation. We had to factor. We had to find the x-intercepts, which we found to be plus 6 and then minus 2 sometimes. But were these the x-intercepts? No, our solutions were actually negative 6 and 2. But the way we found these were through finding the x-intercepts, places where the x will be intercepting our graph. So, the first step which we're going to do in order to solve this equation to find all the values as well as graph them is, honestly, unless they give us a solution point, we have to graph it ourselves and find one solution. So I'm going to go ahead and give us one solution, because the easiest way is either to have a solution and then work with the one solution to find the other solutions, or to find our first solution, to find it on our own and use that solution to get the other ones. It might sound a little confusing, but let's try to deal with this. So, if I told you that one of our answers was going to be, one of our solutions was going to be x plus 4. One of our solutions is going to be x plus 4. We can use that and divide that by our equation to get another factor. It's just like in elementary school when we said 48, and we knew one of our factors was 7. So what's the other factor? Well, it has to be 6, because 6 times 7 equals 48. Similarly, we know one factor, so we're going to use that factor to figure out the other factors. We use that factor into our original equation to find other factors. And to do that, we use something called synthetic division. We could do long division with polynomials, but that's way too time-consuming and way too possible for mistakes. So there's a very easy method called synthetic division, where you just take a solution. So the solution to this equation, if x plus 4 is a factor, then our actual answer is negative 4. So negative 4, draw a box around there, and we have to list now the coefficients of each of our x values in descending degree order. And degree is basically the x value, the exponential value to which x is raised. So first it's 3, so our coefficient is 2. There's no x squared, but we have to put in a coefficient, so let's just say our coefficient is 0. Next, we have 24x to the first power. That's considered 24 to the first power, so we're going to put negative 24. And this is considered x to the 0th power, because x is anything to the 0th power is 1. And so we have to put 32. And now, to synthetically divide, we do something called bringing a number down. We're going to bring a number down, multiply it by a previous number. So 2 times negative 4 is negative 8, and then add them together. Negative 8. Multiply it again, 32. That becomes 8. 8 times negative 4, that becomes negative 32. And then it should equal out 0. If it equals out 0, that means we have no remainder left over. And I like to put a little note here. This is when the degree was 3. And every time we do one synthetic division row, we lose 1 degree. So this becomes 2. The degree number here is now 2. Which means that this is 2x squared minus 8x plus 8. And the 0 means that there's no remainder. If there was a remainder like 1, we do 1 over x plus 4, which wouldn't make any sense. That would mean that our factor is incorrect. That's like having a remainder when you do 46 divided by 9. If you do 48 divided by 9, then that's a good remainder. And that'll have a remainder. But if it's a factor, like 42 here, by the way, if we have 48 and we have like 9, then that's perfectly alright if we have a remainder. But if we say that one of our factors has to be 7, then when we divide and to find the other one, we should have no remainder left over. Hopefully that makes a little sense. But now we have a quadratic. We went from a cubic equation to a nice easy quadratic equation. So equals y still. And we also know one of our solutions, so that's how we did that. Now it becomes a simple matter of solving out this algebraic equation, this quadratic. So first we're going to factor out a 2, x squared minus 4x plus 4. And you can stop right here, and if you notice that this is an sorry, I'm trying to think of the right words. If you notice that this is a perfect square trinomial, then go ahead, you've won the game of life. But if you haven't, then it becomes a simple matter of going into the quadratic formula, which is x, we went over this in the last one, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's just more work for you. But we know I know that this is a perfect square trinomial, so I'm going to go x plus, let me check this out, x minus 2 squared. That's what it is. It's x minus 2 squared. Now what we have to do then is, well, we're going to set this equal to 0. 0 divided by 2 is 0. Well, sorry, I'm completely going crazy here. That means that our value is 2. It ended off being 2. Why? It's because when you solve this out, this becomes 0 equals x minus 2 squared. Square root of 2, square root of both sides. Square root of 0 becomes 0. 0 equals x minus 2. And then x equals 2. So that's another solution. X equals 2. But we have to put it in factored form. So that's actually x minus 2. So now we found two solutions to our equation. Is that the end? My friends, it is not. And that is because I'm going to write this out in huge font. Fundamental theorem of algebra, which says that the leading coefficient's degree of a polynomial will be the number of solutions. It might not be the number of all real solutions, but it'll be the number of solutions. So here we have x equals 3. That's our leading term. Therefore, we must have 3 solutions. So far, we only have 2. So we're missing one more solution, which means we're going to have to do something else. I'm going to go back to synthetic division to get this last root. I understand. I hope I'm making sense. I'm trying to go very quickly because this is a lecture after all. This is supposed to be just a review. I'll spend a lot more time and a lot more detail in my actual pre-algebra thing. So of course, if you don't understand this, please just look into my pre-algebra, my pre-calculus rather. Look into my pre-calculus regular course that will be coming up shortly. So now we have to do synthetic division again with our new solution of 2. Why 2? Because you could do either one. I'm just going to do 2, however, because it's just doing intuition. I mean, there's a reason for it, but let's not go into it too much. Now, 2, we're going to have to use this new equation because we have to go from a degree of 2 to a degree of 1. So we get to put in this coefficients. So 2 is 2. When x to the first power, that coefficient is 8. X to the 0th power, that coefficient is 8 as well. And let's put a little, I like to put a little number in the corner to indicate what kind of degree we're going into. So now let's do synthetic division. Let's just do 2. 2 times 2 is 4. X minus, that's negative 4. Negative 4, that's negative 8. And that should be 0. That's right. We did it. So now this is 1, which means it's 2x to the first minus 4, which also equals 2x minus 4. So now we have to solve this when this equals 0. So let's set this equation equal to 0. And this is a simple algebra equation. 2x equals 2, and then 2x equals 4 rather, x equals 2. So now we have to put that back into our equation and into our factored form. But we already have x minus 2 written one time. So we're just going to square this term because it's saying x minus 2 times x minus 2, basically just x minus 2 squared. And I want to talk about multiplicity after this. which is very important. This is leading me right into multiplicity. I just want to do this example first. Now my question becomes, are we done? And the answer is no, we're not. We still have this coefficient that we left unaccounted for when we solved this out, so we just put the coefficient back in there. And if you didn't catch that mistake being made, all you'd have to do is simply do what I'm doing right now, which means you're going to graph the original equation, 2x raised to the third power. So I'm going into my graphing calculator, I'm typing it in. 2x raised to the third power minus 24x plus 32. And we're going to graph that, and we're going to see that it kind of looks pretty cool. It looks pretty funky. It kind of disappears off the normal scope of our graph. And now we're going to go into y. And let's say we forgot the 2. So let's just type in x minus 2 squared. X minus 2 squared. X plus 4. Hopefully you guys are doing this with me. I'm doing this with the sole intent of hoping that you guys are going to be following along on your respective calculators. I'm still looking for a way to put my calculator onto my computer, but until then, hopefully, you guys are following along with your own calculators. So let's graph this, and let's see that it's not going to look right. It's not going to adhere, especially to figure this out. If you want to type in second, that blue second button in the top left corner, right underneath y equals, the second button, and go into table. And you're going to see that the values don't equal each other. The roots equal each other, but don't worry about the roots, actually. Well, the roots are basically when the x is -4, so let's look for a -4. -4, the y is equal to 0. 2 as well, the y is equal to 0. But it's not right. It's absolutely not right. It's, how can I best put this? There's something missing. And the only thing we can change now, since we already have all the roots, the only thing we can change now is a number in front of it. So 2 would have been picked up in here. So we're going to put the 2 right back into there. And we would have found that now if you insert a 2, so second insert, and inserts right over the delete button, which is 2 spaces over from the second button. Insert a 2. Now if we graph it, they're going to go seamlessly together. And as you can see, all the values now equal each other perfectly. So we've successfully factored an equation down. How do we do it? Let's review one more time because I went a little quickly with this. What we did was, and I'm going to draw this out. First things first, if we don't have a solution on the graph, a factor of the equation, all we're going to do is go into our graphing calculator, type in the equation. So we're going to have to find first factor. And if it's not given to us, all you're going to want to do is type equation into calculator. Type equation into calculator. And then we're going to go into something called the second calc. Second calc. What that does, second over the calc button, which is 2 spaces over from the y equals button, and what that does is it can calculate a lot of cool information about a certain equation for you, and we're going to look for the 0. So we're going to type in 0, and it's going to ask you, well, let's first type in an equation. Let's type in that equation again, 2x raised to the third power minus 24x plus 32. If I type in this equation, and it's going to graph it for me, I got to find a point where x equals, an x-intercept, and if you look at the standard menu, I kind of see one in the negative side of the x, right about where 4 is. I don't know for sure whether it's 4 or not, but I'm guessing it is. So what we're going to do is we're going to go to second, calculate, and the second option from there is 0. We're going to select that, and then it's going to say left bound. So we're going to try to use the 4 arrows, which are right underneath the graph button, up, down, left, and right. We're going to try to go to, there's going to be a cursor, and if you can't see your cursor, you just got to make sure that, try to find your cursor. Okay, I can find my cursor. To navigate where your cursor is, in the bottom left-hand corner of the screen, not the calculator itself, the screen, there's a little number that describes where your x-coordinates is. So I'm estimating that my x-coordinates around -4. So I'm going to move my cursor to where there's -4, and I'm going to hit enter for the left bound. Right bound, we're going to go one step over, so -3, negative 3.8, that should be fine. I'm just going to skip a guess, and it's going to tell us that our first zero of our equation is negative 4. So x plus 4 was a solution. If we didn't get one, that's what we'd do. Next, use synthetic division and algebraic I definitely spelled that wrong. Algebraic properties to find remaining solutions, be them real or be them imaginary. I'm going to go over non-real answers and stuff right after we finish today's tutorial. And I'm going to go over a little bit more into quadratics, and we're going to look at non-real answers, like imaginary answers, and we're going to look at those as soon as we finish this. I hope this was I understand this was a very long tutorial to figure out the answer to our polynomial. However, it needed to be done, and this was the fastest that I could have gone. I want one more example before we finish. Let's try to find a different one. X cubed plus x squared minus x minus 1. Let's try to see if we can solve these, solve out these. Sorry, I'm trying to think again. We have to try to see if we can solve to find the factors. And then in the next tutorial, we're going to look at graphing these. We're going to basically wrap a lot of things up. This is going to be seven because this is already half an hour long of a lecture. So we can do something called factor by grouping, and this was gone over in algebra class. Factor by grouping to figure this out, and we're going to try to take out a common factor. So common factor here will be x squared, which makes this x plus 1 minus 1 x plus 1, and then becomes x squared minus 1 times x plus 1. We extend this page once more, and it becomes x plus 1 x minus 1 x plus 1, so written simply x1 squared x minus 1. I'm going to end today's tutorial by giving you guys a new term, which we will explore when we graph these polynomials. So we could only solve these polynomials in today's tutorial. We'll graph them in the next equation. This is called the multiplicity of a root. And what that means, I'm completely ending this tutorial off on this note, a multiplicity of a root means the number of times a root shows up, a number of times a factor or a root shows up in a polynomial's most factored part of the equation. And that comes when we have to graph them, which is what we're going to do in the next tutorial, in the next lecture. So see you guys until then.